So, good morning, dear friends.
Good morning, sir.
So, today we start a new topic that is differential line elements, differential surface element, differential volume elements in different coordinate systems. Now, as of now, I have told you that first two modules are the fundamental modules of this course. Uh, So suppose you have a surface like this. Okay. So if you are asked to find out what is the flux passing through this surface, then you should know the geometry of the surface. You should know the geometry of the surface. Okay, so unless and until you know you have the correct information on the geometry of the surface, you cannot able to solve the problem. So to view on this, we have uh, introduced these three new terms: differential line elements, differential volume elements, differential surface element in three different coordinate systems. And let us see what are they. So we one by one see. So first of all we have Cartesian system. First of all we have Cartesian system. Secondly we have cylindrical system. Secondly we have cylindrical system. And last of all we have spherical system. Last of all we have spherical system. So we should know, or we should invest at least some time to see what are the differential line elements, surface element, volume elements, coordinate systems. So let us see one by one. Let us first consider Cartesian system. Let us first consider Cartesian system. It is basic geometry of that. This is like this. It is x. This is y, and this is z. So any point P can be defined by x, y, z. As you all know, this is x, y, z. And now this differential line elements. What is the idea of differential line element? Means what is different? What is the definition of differential line element? It is a small line section, small line segment across. It is a small line segment along the respective direction. Along the respective direction x, y, z. Okay. So I repeat my statement. Differential line elements are the differential line segments along respective uh, directions, like x, y, z in Cartesian system, like r phi z in the cylindrical system, and like r theta phi along in spherical system. So if we say the mathematical term, if we write the mathematical term, then the differential line element along x direction, it can be written as dlx. Now as you know, these differential line elements are always vector quantities. Differential line elements are always vector quantities. So it has got a magnitude. So let it be dx. Let it be dx. The magnitude is dx, and the second part is unit vector. So I have introduced the unit vector concept. So it should be ax cap. So similarly, along y direction, it should be dl y. It should be dl y. So it should be the magnitude part is dy, magnitude part is dy, and the unit vector part is ay cap. Unit vector part is ay cap. And along z direction, it should be along z direction, it should be dlz, should be a vector. Then uh, it should be the magnitude part is dz, magnitude part is dz, and the unit vector part is az cap. So these three are the differential line elements. So these three parts are the differential line elements along these three are the differential line elements in Cartesian system: dlx, dly, dlz. All the things are all the line elements are vector because it must have some direction. Must have some direction. A differential line elements must have some direction either in forward direction or in the backward direction. And last day I told you that conventional direction is the always in the positive direction. So it is the direction either in this direction, is the positive direction, or in the reverse direction. But last day I have told you the conventional direction is always along the positive direction. So the unit vectors is always ax cap, ay cap, and az cap respectively. So is it okay with you all differential line element in Cartesian system? Any question? Hello.
No, sir. No, sir. Okay.
No, sir, no, sir.
Okay. So now the next part is surface elements. Okay. Next part is the surface element. Differential surface element. Again, differential surface element is nothing but the a small differential surface. A small differential surface. Now you know surface is a two-dimensional thing. You need to vary two variables at a time. So So I have already introduced the concept of surface. That is, if you vary two objects, or sorry, if you vary two variables and if you keep one variable constant, then that surface is treated as that constant some surface, constant that variable surface. Like for an example, if you consider floor and roof, then it is said that it is a constant jet surface. It is a constant jet surface because for floor and roof, the z is always constant. Okay. So now the question is, surface is scalar or vector? The answer is scalar. The surface is vector. Now, how a vector or how surface is generated? By multiplying or by varying two variables. So either you vary this two differential line elements, you vary, you will get a surface. Okay. So let me write it down. What is dsx? What is dsx? What is meaning by dsx? Differential surface element where x is constant. Similarly, we will have dsy. Similarly, we will have dsy. What is dsy? Differential surface element where y is constant. And similarly, we will have ds z. Okay, we will have ds z, differential surface element along uh, differential surface element where z is constant. So I was I was giving you an example of this surface, particularly dsz. For an example, it is either floor or roof, where z is always constant. Now the question is how this dx can be generated. Now dsx, as I pointed out just now, x is constant. So x is constant means remaining two variable must be variable. X is constant meaning the remaining two variables, remaining two things, that is dly and dlz, are must be varied, need to be varied. So we shall write it down: dly dly that multiplied with dlz, that multiplied with dlz. Now these are two vectors. Okay, these are two vectors. As you all know, vectors has got two products. One is dot product or scalar product, and other one is cross product. So these two type of product is associated in case of a vector. One is dot product or scalar product, and another one is cross product. So my question is you now, what do you think?
Sir, cross
DL,
product.
DLY and DLZ must be product in which dot or cross.
Sir,
So,
cross.
so why cross? What do you think? What is your opinion? Why cross product?
Sir,
Why not
dot
dot
product.
product?
Sir, dot product is happen when the two value is same.
Mm, you have very wrong conception. Any vector of any magnitude can be done with dot product. No harm in that. Any vector can be taken as to dot product. Any vector with any magnitude. So your explanation is wrong. So any other answer? What is y cross or what y dot? What do you think? What is your opinion? You see, this must be either dot product or cross product, right? So my question is, what do you think? What is it, a dot product or is it a cross product? So one friend of yours has said it is a cross product, but he has not justified his answer. So I treat that answer to be a wrong one. So I am sorry for that. So anyone wants to try? Anybody wants to try? Okay. You see, when you doing this a dot b, when you doing this a dot b, it will yield the resulting of this dot product will yield always a scalar. Okay, will always yield a scalar. However, if you are doing cross product, the resulting of this cross product will always be yield a vector. Now you see what is the resulting. What is the resultant here? Resultant here is itself
dsx
it's a
vector.
vector. Itself is a vector, so it must be a cross product. It must be a cross product. So let us evaluate that cross product. So you just substitute, dly is dy ay cap and dlz is dz az cap. So if you take magnitude along dy dz, then you will having dly means ay cap cross az cap. So as you know from the previous lecture, what is ay cross az? Ay cross az equal to ax cap. So ultimately the result will be dy dz ax cap. So very interesting result. Dy dz ax cap. It's very interesting result. You see, it is the magnitude part. Dy dz is the only magnitude part. However, ax is the unit vector part. So what does it signify? dsx. It's a vector quantity. That is the constant x surface is the vector quantity, and it is directed along positive x direction. It is directed along positive x direction, right? Similarly, if we do dsy, so rest of the two variables must be multiplied. So it will be
Sir, DLZ cross DLX product vector.
yes dlz cross dlx. So if you take my magnitude apart, so it will be dx dz. It will be dx dz. It's the magnitude part, and the if you see the dlz is az cap cross ax cap. So the ultimate result is it
Mod
is
of DX
dx
DZ AY cap.
dx dz ay cap. So what does this result signify? Signifies that its magnitude is dx dz. You see, it's the x and z are variable here, and it is directed along positive y direction. It is directed along positive y direction. Okay, and finally, if you have done dsz, so it must be dl x cross dly. Okay, so magnitude wise it is dx dy, magnitude wise it is dx dy, and the unit vector part it is ax cross ay, ax cap cross ay cap. So the ultimate result will be dx dy
AZ cap.
z cap. So you see from the result itself, you see x and y are variable, and it is directed along az cap means positive z direction. So this is the concept of differential surface element. This is the concept of differential surface element in Cartesian system. Okay, so all differential surface elements are vectors. All differential surface elements are vectors. Any doubt you can ask me.
No, sir.
And then you have no doubt. So if you look at these are the ultimate result. This rightmost expressions. So dsx is nothing but dy dz ax cap. Dsy is nothing but ds dz ay cap, and dsz is nothing but dx dy dz cap. Okay. So these are the differential line elements. These are the differential surface element, and finally we have left with differential volume element, and it is represented as dv. It is represented as dv. Now differential volume element, again it is a small differential volume, but volume is generated by three variables. So volume is a scalar quantity because if you choose any volume, it has no directions to move. If you moving it to any direction, that means a particular surface is moving, but not that volume it's moving. So dV in that respect, dV is a scalar quantity. So dV, you see, if you look this dsx. So in this term is y and z is variable and x is constant. So again with this dsx differential surface element, if you again vary dlx, then you should get the total volume. So it must be, you see, this dlx, you must multiply it with dsx. Now please can you tell me which product it should be?
Sir,
Whether
dot product, sir, dot product.
because the resultant is a scalar, so it
Yes.
must be
Yes,
a
sir.
dot product.
Yes, sir.
Now you see dlx is dx and dsx is dy dz. Okay, so the magnitude is dx dy dz. Magnitude is dx dy dz, and you see the angle is dlx, you see x cap, and it should be dotted by, again you see dsx is ax cap. So ax dot ax, it is 1, isn't it?
Yes, sir.
So
Yes, sir. Yes, sir.
dv is nothing but dx dy dz. So this is the result. This is the result of differential volume element in Cartesian system. It is dx dy dz. So this is how these formulas are coming. So in your school level, in class 9 or 10 standard, you used to solve mathematical problem in a, suppose a cube or a rectangular parallelepiped was given where x is length is this much, breadth is this much, and height is this much. So what is the volume of this volume of that room? You straight away multiply these three dimensions, length into breadth into height. Now how they are generated, it is the explanation. How they are generated, this is the explanation. The differential volume element is dx dy dz. So any question?
No, sir.
No, sir.
So this formula exactly mentioned in this note. You see, for Cartesian system, these are the differential line elements. For differential surface element, these are the differential surface element, and differential volume elements are this. dv is equal to dx dy dz. So how, what is the explanation, how it is coming? The explanation is given in this class. So are you okay with it?
Yes, sir.
Oh, it is okay, then fine. Let us move to our next slide for cylindrical system. Let us move to our next slide, that is cylindrical system. now you know for cylindrical system, if this is the system, it is y-axis, it is x-axis, it is z-axis. So any point is defined by r theta phi.
Sir, R phi Z.
Oh, sorry, r phi z. So this is the definition. Okay. So similarly, we can think there are differential line element along r direction, differential line element along phi direction, differential line element along z direction. So we must have, and indeed we have that. So let us write it down. What is differential line element along r? So DLR, it should be dr ar cap. Okay. This is DLR, that is differential line element along r direction. It is dr ar cap. Differential line element along phi direction. Now it should be little different. It should be not d phi ar fi cap. It should be r d phi fi cap. Okay. And similarly, dz dlz, it is equals to dz, it's a magnitude, and angle is not angle, its direction is az. So these three are differential line elements. These three are differential line elements. Okay. Any doubt?
স্যার ডিএল ফাই এর ক্ষেত্রে আর ডি ফাই যেটা হলো স্যার ওটা একটু এক্সপ্লেন করবেন?
Because suppose this is the xy plane. Okay. Suppose this is the xy plane.
স্যার লেফট হয়ে গেছে।
ইয়া বস।
হ্যালো
বস তুই ক্লাসটা এবার শুরু কর।
বলো।
আকাশ ভাই, তুই কন্টিনিউ কর।
Hello, am I audible?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
So
sir, you are audible.
how far you have heard?
Yes, sir.
Connection was lost. How far you have heard?
তো আপনি স্যার ওটা ডেসক্রিপশন করতে দিলেন মানে
Sir, sir.
ডিএল ফাই
RD phi টা sir, RD phi.
Okay. I was telling that I am omitting z variable because in Cartesian system and cylindrical
Sir,
system.
you are not sir presenting, sir. Your screen not visible.
Okay, sorry. Now is it visible?
Yes, sir. Yes, sir.
Yes, sir. Visible.
I was talking about, I was telling you all that I have omitted here z variable because in Cartesian and cylindrical, the definition of z is same. So I am omitting z. So let us say this point is P dash, which is the projected point, probably any point from the sky. Okay. So this was your R and this was your phi, right? So it is the definition na, from origin to that projected point it was R, and this angle with the positive x-axis it was phi. Phi. Agreed?
Yes, sir. Yes, sir. Yes,
Okay.
sir.
So now if you, let me choose a different color. Now if you choose a differential line element like this, now if you choose a differential line element like this, so it becomes dr. Let us say it was initial point was P dash, now the final point, the incremented point be P double dash. Okay, so this red line is the differential line element along r direction, so it is dr and it is directed along positive r direction, so dr ar cap. Okay, now let us see, we have incremented a small amount of d phi. So the whole line segment will become like this. Let us say this is d phi. So if you incremented a small value d phi, so the whole line segment will become this. Now ultimately this green line will become dl phi. So now you tell me what is this dl phi is equal to? If this is r, if this is d theta, then what is this arc is equal to?
Also, R into D, sir.
Yes, so that is the explanation. It is r d phi. R d phi, and it is directed along positive phi direction. So that is why it is a phi cap. Okay, you now understood.
Yes, sir. Yes, sir.
So let us go back to my previous slide. So it is r d phi az cap. Okay, so these are the three differential line elements. So now with the same logic like the previous one, we can establish differential surface element along r direction dsr. So that is equals to dlr, not dlr, it is dl phi cross dlz. It should be cross product, right? So the result is, now the magnitude, I am writing it directly. Now for the magnitude part, it is r d phi dz. It is r d phi is r d phi dz. It is the magnitude part. And the direction part is, see, a phi cross az. It should be a phi cross az is ar cap. A phi cross az. It should be a phi cross az. A phi cross az. It should be ar cap. So that is why I have written here ar cap. So similarly, we have ds phi, differential surface element along phi direction. So again it is dlz cross dlr.
DLR.
You see the magnitude is dr dz. See, it is the magnitude is dr dz, and the direction is, you see, az cross air,
Fi cap.
az cross air, it should be is equal to a phi cap. And lastly, if we evaluated dsz, so it should be a dlr vector crossing with dl phi. Okay, dl phi. So magnitude is, you see, r dr d phi. Magnitude is r dr d phi, and the angle is, or not angle, the direction is ar cap cross a phi cap, that will be is equal to az cap. So these are the three differential line elements along sorry, not line elements, it is the differential surface element along respective three directions. Any doubt?
No, sir.
Wait. So now what is dV then? What is dV? So like the same way, if you do dlr, it should be dot product with dsr, should be dsr. So the magnitude wise, it should be r dr d phi dz, r dr d phi dz. And you see the angle wise, again I am telling angle, not angle, it's direction wise air dot air, so it becomes 1. So it is the result for dV, r dr d phi dz, r dr d phi dz. So if you go through this note PDF, you will get to see that exact these expressions are given there. You see, exactly the same expressions are given there. So we now another thing, how they are coming, it is, I have already explained you in the last class, it is according to the right hand system. It is according to the right hand system. I am giving you 1 minute time. Now, sorry, are you there?
Yes, sir.
Yes, sir. Yes, sir.
Now I can give you a small exercise. Right now you can do it. Uh, you integrate this expression dv, you integrate this expression, means you need to evaluate the total volume by this expression. So I am giving you the range 0 less than equals to r less than equal this 0 less than equal to phi less than equal to 2 pi and 0 less than equal to z is h. So if you have these limits of these three respective variables, can you tell me what is the volume? Anybody? I hope you know how to calculate triple integral.
So 2 pi r h.
Sorry? Sorry, any answer? It's a simple integration. Anybody? Any answer? I should expect at least one answer. I am just giving you a very easy exercise. Using this formula, dV is equal to R dr d phi dz, you need to evaluate total volume. I have given you the range. Hello?
Sir, 2 pi r h.
No, not. It's not 2 pi r h. You see, it is not only dr, it is r dr. The integration of r dr is r square by 2. It's not 2 pi r h. Please, at least give me the correct answer here. Otherwise, I will be very disappointed with you all. What is the integration of dz? Hello? Are you there?
Yes, sir.
Yes, sir. Yes, sir. Sir, Z.
Are you try na? Please, at least you give a try. What is the integration of dz? The correct answer is pi r square h. Very shameful for you all, I must tell you. It is pi r square h. What is this pi r square h? Do you remember? Or do you figure it out? Hello? What is this pi r square h? Can you figure it out? Hello?
Yes, sir. Volume, sir.
Volume of what?
So always a cylinder. Shunku type.
Yes, that is why
Cylinder.
you see when you are configuring, you are dealing with cylindrical coordinate and you are calculating total volume. So it is coming out the volume of a cylinder. So even if when you have done the problems on mensuration in your 9-10 standard and when you have cylinder, so you have heard those formulas. It is pi volume pi r square h, lateral surface area 2 pi r h. So those formulas you have learned. So how they are coming, how they are generating, these are the explanations. Okay, these are the explanations. So now next we move to the our next final segment. It is spherical. Spherical. It is represented by x, y, z. Any point P is defined by r theta phi. R theta phi. So similarly, we are writing DLR. It will be dr magnitude and direction is ar cap. Next to it, it should be dl theta. It should be r d theta. So magnitude. The angle is a theta cap, and next to that it should be dl phi. So its magnitude is r sine theta d phi, r sine theta d phi is the magnitude, and the direction is a phi cap. So these are the differential line elements. So what are the differential surface elements? Let me write it down quickly. Differential surface elements are first ds r, that will be is equal to that will be is equal to dlr dl theta cross dl phi. So it is result will come as the magnitude part r dr d theta, and the direction part is ar cross a theta. As per right-handed system, it must be a, sorry, not, it must be a theta cross a phi, must be AR cap. So A theta cross A phi, it should be AR cap. So next you have ds theta. What is ds theta? So in the first term you have dl phi cross,
স্যার ডিএস আরটা স্যার হ্যালো স্যার
yes,
স্যার ডিএস আরটা স্যার আট স্কোয়ার সাইন থিটা হতো না?
सर डीएसआर तो आर स्क्वायर डी थीटा साइन थीटा डी फाई होता है ना।
sorry, r square sin theta d theta d phi, d theta d phi. Now is it okay?
यस सर।
So ds theta is equal to, so dl phi cross dlr. So magnitude it will be r sin theta dr d phi. It's the magnitude as the angle is, or not angle, direction is a phi cap cross ar cap. It's as per right-handed system, it should be a theta cap. So it is a theta cap. And finally you have ds phi. So it will be dlr cross dl theta. So magnitude it will be r dr d theta, and angle it will be ar cross a theta, it should be a phi cap. So you see dsr is acting along r direction, ds theta is acting along theta direction, and ds phi is acting along phi direction. So these are the differential surface elements. Now if you can quickly figure it out what will be the dv, I will be very happy for you.
আর স্কোয়ার সাইন থিটা ডিআর ডি থিটা ডি ফাই।
Yes, simple. R square sin theta dr d theta d phi. Let me write it down. So dv is equal to r square sin theta r square sin theta dr d theta d phi. So this is the formula for differential volume element. So now you please give me the result. So if I give you the uh, range, say 0 r is varying from 0 to capital R. Let us say 0 pi. Theta is varying from 0 to pi, and pi is varying from 0 to 2 pi. So can you give me the volume of this E? Anybody?
Sir, 4 by 3 pi r cube.
4 by 3 pi r cube. What is this? Can you figure it out? Can you figure it out? What is 4 by 3 pi r cube?
The volume of sphere.
Volume of the sphere. That is why this system is called spherical coordinate system. That is why this system is called spherical coordinate system. So all those problems you have done in your 9-10 standard, cylinder, sphere, cone, all you have got the formulas: pi r square, 1/3 pi r square, 4/3 pi r cube, dA, length into breadth into height, circle pi r square. All those formulas can be derived from today's discussion, and those formulas are being derived from here. Okay, so please tell me if there any question. Now if you go back just one slide back, so you see dsz is equal to r dr d phi. dsz is equal to r dr d phi. You so let us you see dsz is equals to r dr d phi, and it should be az cap. You forget about this direction part. So if I give you the range 0, r is varying from 0 to capital R, and if phi is varying from 0 to 2 pi. So can you tell me what is the surface area? You forget about this for the time being. You forget about az cap. You just treat only magnitude part.
The pi r
So if
square.
you yes, the answer is pi r square. What is this pi r square? What is this pi r square? Can you figure it out? Can you recognize what is pi r square? Anybody?
How is the area of?
Area of the circle.
Yeah. Yes, sir.
Area of the circle. So you see the everything can be derived from this discussion. In fact, those formulas were derived from here. Like in this formula, can you this formula? Let us say ds theta that is equals to ds theta is equal to r sin theta dr d phi. R sin theta dr d phi. A theta cap. So can you integrate and tell me what is the surface area is equals to? I give you the range r this, phi is this, and let us say theta is constant here, pi by 2. Theta is constant here, let us say it is pi by 2 because it is a theta constant surface. So can you tell me quickly?
So 4 pi r square.
R square by 2, 4 pi r square. What is that? R dr it is r square by 2. R dr it is r square by 2. And phi is 2 pi. How you are getting 4 pi r square? It is pi r square only. Okay. Wait a minute. You integrate this r square sin theta d phi. R square sin theta d theta d phi. I'll give you the range. You said r equal to capital R. You consider r equal to capital R. Phi is okay, and theta is 0 to pi. 0 to pi. Please solve it and tell me what is the answer. Anyone? Anyone? Please,
So
this
2
is
by
the
3.
range. Sorry,
So 2 by 3 pi r cube.
2 by 3. Is it?
Pi r cube, sir.
R square. Why it should be r cube? R is constant here. From where you are getting r cube? R is
Okay, sir. Okay, sir.
constant
Okay, sir.
here.
So this is 2 pi r square.
2 pi. So this is the one part. And if you do the reverse part, so it will generate 4 pi r square. What is 4 pi r square is equal to? Okay, you forget about this 2 pi r square. Can you recognize what was 4 pi r square? It is the lateral surface area of the sphere. It is the lateral surface area of the sphere, if you remember. So 2 pi r square means you have taken 0 to pi, is theta. So if you take the reverse part, it is the surface lateral surface area of the semisphere, half sphere. So if you consider the full sphere, it will come as 4 pi r square. So everything it can be solved. Every formula that can be derived in this way. Okay. So if you have any question, you can ask me. Otherwise, I can show you the formulas. You see, for the spherical, these are the formulas. If you have any question, no question from your side.
No, sir.
Okay. So this is all from my side for today. If I today start a new topic, I cannot able to finish. I just want to make a mention. You see, today next class I will start first solve some problem. Then I will go to the vector calculus. So you please see this table where you can see, you see this H1 I have termed as 111 for the for Cartesian system. H1, H2, H3 all are from 111. For cylindrical system it is 1r1, and for spherical system it is 1r sine theta. What are they? I need to mention here that you see in Cartesian system, you see the coefficient of dx, dy, dz are all one. So that is why it is written here. It is all 111. Now, if you go to the cylindrical system, it is dr 1 into dr. Now for d phi it is r, and for dz it is again 1. So it is 1r1. It is 1r1 for cylindrical system. And if you go further, for spherical system it is 1r sine theta. So those coefficients which is mentioned in the PDF, h1, h2, h3, h1, h2, h3, these are called metric coefficients. In case of Cartesian, all are 1. In case of cylindrical, it is 1r1. In case of spherical, it is 1r sine theta. So there it is for Cartesian, it is for cylindrical, it is for spherical. And what is h1, h2, h3? They are called metric coefficients. They are called metric coefficients. So you please remember these three values: 111 for Cartesian system, for cylindrical it is 1r1, and for spherical it is 1r sine theta. So far I have all to say for today. So if you have any question, you can ask me. So let me stop the recording. If you do not have any question,
No, sir.
yes, you have.
No, sir. No, sir. No question.
Oh, so thank you all. So next class we shall meet on next week. Thank you.